Hi, today I'm going to introduce MATLAB chain and how they works by two kind of methods to realize it. Mutual exclusion is the use of repulsive force between the same magnetic field as the support and guidance of the train. Since the train is equipped with superconductor electromagnets, when the train moves through the guide rails via external forces, the magnetic field generated by the superconducting magnet also move, causing the ground cores to generate induced currents and the currents to generate magnetic fields. These two kinds of magnetic fields are oriented the same. So the train and track will produce repulsive force. The train thus suspended and then use a linear motor to advance. Because the two magnetic field forces balance each other, the train can maintain a certain elevation height about 10 to 15 centimeters. Because the magnetic repulsion phenomenon of repulsion does not exist when the train is stationary. The train must first move by external forces to generate induced current and magnetic fields. Therefore, the train is equipped with wheels for takeoff and landing. Actually, when the speed is 60 km per hour, the wheels are still in contact with the ground. When the car is accelerated, the body will gradually float. The train uses this suspension system. Suction type is the use of attractive force between the opposite magnetic field as the support and guidance of the train. Most of the bottom of the body of the train has a C-shaped cross section over the guide rails. When energized, the electromagnet produces a magnetic attractive force that attracts the train forwards, and the train sinks due to gravity. When the gravity of the car body is balanced with the attractive force of a magnet, the train must float away from the track about 1 centimeter. The size of the gap will change with the strength of the magnetic force, so the train is an extremely unstable state. The major advantage to sustained maglev system is that they work at all speeds, unlike the other one, which only work at a minimum speed about 30 km per hour. This estimates the need for a separate low-speed suspension system and can simplify track layout. On the downside, the dynamic instability demands fine track tolerance, which can offset this advantage. Someone was concerned that to meet the required tolerance, the gap between magnets and trail would have been increased to the point where the magnets would be unreasonably large. In practice, this problem was addressed through improved feedback systems, which support the required tolerance.